So in today's lecture, we are going to start something new, which is about separation of mixtures by the physical mean. You should be clear that these mixtures are those substances who are going to stay with each other, who are going to might be miscible or immiscible with each other, but they are not soluble or chemically reacting with each other. Just like if I place sugar and sugar will be soluble in water, it is a mixture, but they are not chemically reacting with each other. If we separate mixtures by the physical means, by using physical procedures or methodologies to separate them, this is a way of separating them. Now, physical means like things, just like changing the temperature. If I boil the liquid, it means I'm going to change it. I'm going to make something to got evaporate and left over something pure, or dissolving one part of a solvent such as water. I mean, like if you got two solutes, you will be separating one of them to, I mean, like you should be clear that at least one of the solute should be soluble in a solvent, so that one would be got mixable with the solvent and the leftover solute will be the impure one. For example, the best example is of the iron and sulfur. When it comes to iron and sulfur, these two are, these are examples of metal and non-metal. So basically, the first thing is that if it is iron, iron is something who is going to be grain color. It is a metal. It belongs to the transition. It is a transition metal basically who is eligible to possess more than one valencies on it. So basically, iron, the symbol for iron is Fe, and iron is a metal. Now that transition metal is able to, the transition metal is going to donate. I mean, like it is going to deal with the donation or exception of the electron. Okay. Another thing is that it is able to attract the magnet. So it have ability to attract the magnet. So we might use a magnet to separate iron from the sulfur. Since sulfur is not a transition metal, it is a non-metal who is going to accept the electron. Now when it accepts the electron, it is obviously not eligible to attract the magnet. It is going to show no behavior towards the magnet. Next thing would be, what if we make a combination of iron and sulfur? They'll be termed as iron sulfide. So simply they will be, like iron and sulfur, they two will got to react with each other. They give rise to iron sulfide. And what would happen though? We need to separate them. So the best way is to use them to place magnet nearby them. Iron will got attracted towards the magnet and sulfur will stay in the solution. Okay, now simply the next possibility is going to be when you would separate, how you can separate hydrogen and oxygen from each other. So simply for that case, if you got a mixture of water and oxygen gases, you can separate them by the physical processes. Oxygen is going to condense into liquid at a much higher temperature than that of oxygen. Okay, so let's say its temperature is 183 and opposed to the one for the hydrogen, which is 253 degrees. So simply this will leave you with liquid oxygen because it condenses. It takes more time to get converted into liquid. However, hydrogen gas would leave the solution by converting itself into the gases. Hydrogen will got evaporated quite easily, while water, oxygen would got converted into the liquids. In a way, we can separate them. The amazing fact of this procedure is that you can simply use melting and boiling points. One way to check out the purity of the substance, other way to separate them. The first thing would be there that if an element is a pure, it is going to boil at its normal temperature. I mean, like if it is going to be boiled up at its own boiling point. If it is impure, it will be melting off at its fixed temperature. Now, if we feel there is a decline, what will happen in case of impurity? In case of impurity, we might see elevation or increase in the boiling point, simply elevation in boiling point, or decline in the melting point is a symbol of impurity. So when we say that these two factors are there, the substance is going to be impure. Impure means mixture of substances are there. Now, when something is pure, pure means only one type of atoms are present in a substance. Okay. Now, the next thing is going to be when you got common table salt and you are going to dissolve into certain. So, I mean, like certainly, if I mix up salt into water, it means it is not impure now. Earlier, if only water was present, water boils at its normal boiling point of 100. Now, if I place some salt into that water and it will be boiled at 120 degrees, might be 100.2 degrees, it is simply a clear demonstration that water is not a pure solution anymore. So in a simple way, you can say that if I try to freeze that impure water, it will show decline in its melting point. I mean, like when it was pure, it was soluble at, it was melting at 0 degrees. But as soon as it is phased as an impure one, it would be. I mean, like if we see that it is impure, then in that case, its melting point is going to be in negatives. So just like you could say that it could be zero point 0.5 degrees, 0.6 degrees. So to summarize all of this thing is that melting boiling points are going to help us to identify the purity of a substance. If something is pure, it is going to be boiled at its fixed boiling point. If it is impure, it is going to melt at the melting point, who is I mean like simply elevation in boiling point and decline in melting point is a symbol of impurity. Because if something is pure, it will boil at fixed temperature and melt at fixed temperature rate. So I hope this is clear so far. Is there any problem you can ask? So make sure to hit the like button, subscribe to the channel. Good luck.